So the problem was a 35 gram bullet moving at 475 meters per second strikes a 2.5 kilogram wooden block that is at rest. The bullet passes through the block, leaving at 275 meters per second. How fast is the block moving when the bullet leaves? So here's what you were supposed to do with that. Let's do given, find, and solve here. Let's zoom all the way out. Okay, so given, you want a before and an after picture in a collision. So before, we had a bullet, and here's the wooden block, and we'll put a frictionless surface here, and the bullet is moving really fast, and the mass of the bullet is 35 grams. You have to change that to kilograms by moving the decimal over 3 times. That's 0.035 kilograms. Now the block has a mass. We'll call it m sub little b for bullet. And then this is, I'll call this big B. The mass of the block is 2.5 kilograms. And it's at rest. So the initial velocity of the bullet is given to be 475 meters per second. So you have to do that before the before picture. And then here's after. I'm going to draw it right below it. So the bullet goes all the way through the block. Here's the ground. Let's draw the ground. So it went, drilled a hole through it, and here's some, maybe some minor splinters coming off. But there's the bullet, and it's still moving. And the velocity of the bullet final was given to be 200 and, was it 75?
Yes.
Meters per second?
Yes.
And they have the same mass. And we want to know, let's find the mass of the velocity of the block, the final velocity of the block. And one other thing we should say is the initial velocity of the block is 0. It's at rest. And so let's solve it. Now the main thing to do here is to start off with the basic principle of physics, that momentum is, nice, the momentum is conserved during a collision. Now, this is the total momentum of both objects added together. Has to be equal to the total momentum of both objects added together after the collision. So I want, when you do this, I want to see this. This is where you start. So where is the momentum? Well, it's the mass of the bullet times the initial velocity of the bullet. Now I look at the block. The block isn't moving, so its momentum is 0. So I'm just going to leave it out. Say all the initial momentum is in the bullet, but afterwards we have the mass of the bullet times the final velocity of the bullet is plus, not equals, plus the mass of the block times the final velocity of the block. So here we have an equation where we know everything except what we're trying to find, which is a good thing. So now I'm going to solve for the final velocity of the block. So I'm going to subtract this to the other side, and I'm going to factor out the mass of the bullet. And then I'm going to divide by the mass of the block. Now I'm going to plug in my values. The mass of the bullet is 0.035 kilograms. The initial velocity of the bullet is 475 meters per second minus 275 is the final velocity of the bullet, divided by the mass of the block, which is 2.5 kilograms. Get your calculator out and do that. See, that's 200, well, you would need a calculator for that. And I think you should get 2.8 meters per second if you round it off. Okay. So there'll be a problem very similar to that on next week's exam. The main thing, do give and find and solve, draw before the collision, after the collision, start with basic principles, then you examine, inspect the problem, and then you just, after that it's math. After that it's math. From here down to here is physics, and then the rest of this is just the mathematics. Okay? That is all.